Okay, so here's just a little bit of extra help for section 1.5 out of the book. I'm just going to do a few of the problems from homework. I also have the answers shown up there online too, so if you can't figure out how those work out, then you kind of need, I guess, come in or find a friend or something to work those through. So here we go. I'm looking at a left-sided limit. Okay, that's going to be important for us, that I think about I'm coming in from the left of -1. Okay, now, what I have to start off with is the fact that, there's two things for this, to do the algebra for this. One is that this is really 1 over x squared minus 2x minus 3 to the 2/3. Okay. The other thing then is the fact that I'm going to have this factor as well. It's x minus 3, x plus 1, that whole quantity to the 2/3 power. Excuse me. So when I look at this problem, before I do the limit stuff to it, I've got to recognize that there is an issue with me plugging in -1, which is why it's a left-sided limit, not actually -1. If it were -1, this would give me 0. So this is the part that's kind of hard to just sort out. And there's also going to be one little extra thing. One little extra thing going on. I'm going to take this to the 2/3 power. So there's a lot of number sense really going on here. Okay, so first of all, what might make it easier for some of you is if you put this to the 2/3 power as well on top, because 1 to the 2/3 is the same thing as 1, and the reason is you can now look at this whole quantity as 1 over x minus 3, x plus 1 to the 2/3 power. Okay. That's one way to kind of sort out the algebra to make it easier. Otherwise, just go down here and I'll kind of have to explain a couple things with it. But this part here, I've not found good notation for it. I'm not going to lie. I don't really know what the best way to think of this is. But we're looking at x being going to -1 from the left. Now, the reason I have to do it is because of this part here. I have to do it from the left here. It really doesn't matter for this guy. I could think about just plugging -1 in. So -1 minus 3 would really give me -4. I'm going to put quotes here because it's not really -4. That's just the value it's approaching. Okay. Now, this guy here, when I plug -1 in from the left, and this is the part where I don't really know great notation for it. When I go -1 from the left, that means a number a little bit bigger than -1. That means something like -1.0000.1. Something like that, really close to -1, but on the left of it. Now when I add that to +1, I'm going to get essentially this to cancel off, and I'm going to get negative the rest of the stuff. And this is where I have a tough time with. I'm going to call it quote-unquote -0. It's not really 0. It's just a little bit left of 0. So if I multiply these two guys together, I'm not going to get 0. Okay, I will get a positive though, because this will always be a little bit less than 0. This will be always close to -4. So this will cancel off. And really, 4 times a number really close to 0. Okay, if you need to get your calculator out, do 4 times, throw mine in front of here real quick. Hopefully it shows up. Whoa, screen. It's my college calculator. Yeah. Let's clear that off there. It's a different problem. 4 times 0.00000000000001. Okay, all those zeros I can type in there. What do I get? Something really close to 0. That's 4 times 10 to the -13th power. Okay, so I'm going to get something that I'm going to call approximately 0 when I multiply those two together. So what I'm saying is 1 divided by teeny tiny number. Well, what's that always go to? We talked about in class. That goes to infinity, quote unquote. Again, I'm using quotes because those aren't numbers, those are ideas. And now I'm saying, oh yeah, take the, square it and then take the cube root. Well, it's infinity. So this guy ends up becoming then infinity in the end. It blows up to infinity from the left-hand side. Okay. If you wanted to, you could look at the graph and see that. You plug into your calculator to see it goes towards infinity. Now, the other way to look at this problem is to come back over here and leave this not as to the 2/3 power, just leave it as 1 over whatever. Again, what we'd have to realize is this guy's going to be -4, quote unquote. This guy's going to be -0, quote unquote. So I get this, quote unquote, +0 small number. But what I really have is 1 over, quote unquote, 0 to the 2/3 power. And what we have to realize is that this number is going to get smaller and smaller still, because the 2/3 power makes it get smaller. So we're still going to get 1 over almost 0. So that gives us then again infinity. So it's probably easier just to think of this as infinity and taking the 2/3 power. But either way, you're going to have to get to the point that it's 1 over something teeny tiny, and that's going to go blow up to infinity. Okay. So hopefully that all showed up. I kind of realized I was looking at the paper and not at my screen. But this in the end has a limit of infinity. Okay. Now, number 8. Number 8. Okay. X times secant squared x. First of all, for any of these, secant we don't work too well with unless you're really, really good doing your trig functions in your head. It's probably going to have to be x over cosine squared x. Have to think of it that way. And that ought to be a tip right there that we're going to run into problems because, pi over 2. Go to my unit circle. What's the cosine of pi over 2? It is 0. Which means I can't do this limit. More importantly, it means I have to look at the left and the right side limit. I have to go as limit as x goes to pi over 2 from the left. Limit as x approaches pi over 2 from the right. Okay, I have to look at the two-sided limits for this. And I get x over cosine squared x, x over cosine squared x. Now, the numerator is not a big deal because whenever I think of that, again, with these, if it's something that's not a problem of being a 0 anywhere, I can just think of plugging the number in. So there's really going to be pi over 2 on top. So it's like number over something. And it's like pi over 2 is like 1.57 because it's half a pi. So we have number over cosine squared x. So our real question is this. Whenever I plug in a number a little to the left of pi over 2, that means over here on our circle or over here in our circle. Well, what's happening? Actually, sorry, this is the left. It's pi over 2 from the left here on this side. This is pi over 2 from the right here. Even though drawing-wise it's from the left, but remember this is 0 radians, pi over 2 radians, pi radians. I'm getting bigger as I go around the circle this way. So this actually is to the, even though it's drawing from the left a bit, it's really from the right numerically. But either way, it's okay, because here's what I got to realize. Oh, I'm going to just get really close to 0. Okay, so I have number over something close to 0, which should blow up to infinity. However, our problem is we should see is, oh, wait a second. When I go right, when I go past pi over 2, which is what I'm doing here, oh, this is where cosine gets to be negative, because over here is -1, 0. So I have now this as number over -0, quote unquote. So shouldn't this blow up to negative infinity? Well, it would, except we got to remember this is cosine squared. So this positive 0 business isn't an issue because when I square it, it stays positive, goes to positive infinity. This guy here, -0 squared, oh, that goes to positive 0, also blows up to positive infinity. So the left side of the limit and the right side of the limit match. Hey, guess what? Even though it doesn't technically exist, we talked about this in class, no, there's no limit because it's unlimited, but they both have the same behavior going to infinity, so we call this infinity, just for the sake of that's what's happening in the problem to tell somebody. Okay. Now the rest of these I think are a lot easier. I think those were two of the really trickier problems from this section. So 18. Okay. This one we get to default and go back to our trick from the first part of 1.5. Hey, look at the highest powered term in the denominator. It's an x squared. Divide everything by x squared. What we really get is 2 sine of x over 1 plus 4 over x squared, limit as x goes to infinity. Now the reason I picked this is to remember that sine oscillates. Okay, sine goes over and it goes back and forth over and over and over again. So the question is, if I get 2 times oscillating, you know, going up and down, up and down, up and down, over 1 plus, really when I plug in infinity here, 0, what does that happen to? I'm sorry. So this is oscillating, so 2 times oscillating divided by 1 plus 0. So the question is, what happens there? Well, let's take a look at a graph. Come on, graphing calculator. The question is, I guess, basically, is this going to oscillate forever? Okay. So, going back to the original problem, 2 times x squared times sine x divided by, excuse me, x squared plus 4. Graph it. Okay. So we looked here to see, okay, well, what's going on? Well, sometimes it's hard to tell from the graph. Let's look at the table. So let's see, what's the graph doing? Numbers are getting bigger. Are they leveling off? Well, they're going over 1. You know what? Let's look at what's happening when x is 600. Oh, they're going negative all of a sudden. Okay. Make sure my mode is in first of all. And I'm in degrees. That's why. Okay. I was like, something's weird going on here that shouldn't be happening. Darn it. Let's look at the graph again. Okay, good. I was starting to freak out. Actually, I was like, this is not working out the way it's supposed to. Okay, good. We should see this. I was like, we should have seen oscillating behavior. We were seeing it, but it's just very slow because we were in degrees instead of radians. So yeah, what's going to happen is this. You know, it's nice and all. It cancels. We get 2 times oscillating over 1 plus 0. Because the oscillating does not get canceled off, our limit actually does not exist in this problem. Okay, so that's one of the things you have to be aware of with sine, is that since sine has a wave to it, it oscillates up and down. Even though it's doing it slowly, it never really gets to cancel off. So this guy goes to does not exist. How disappointing. Okay, now number 20. Okay, number 20. Again, we have some polynomial portions to this. So that would be our first thought, is let's take care of that by dividing everything by x. Okay, that then gives me the limit as x goes to infinity of sine x over x minus 1 over sine squared x over x plus 3. Now, the key to this is, yes, sine's going to oscillate. Sine squared is going to oscillate as well. It bounces, but it does, you know, go up and down. But the real key to this is thinking about, oh, I'm going to plug in infinity. And what does sine move between? Well, sine moves between -1 to 1. That's all the values for sine x. So I'm saying everything's going to go between -1 to 1 and go to infinity. So this guy here is between -1 and 1 and over infinity. Well, guess what that's going to go to? It's going to go to 0. So this guy's going to go to 0. Okay. All right. Sine squared x, well, I'm going to square it. So this is going to square, so I'm never going to be negative. It actually oscillates between 0 and 1 over infinity. Well, again, if I do 0 to 1 divided by infinity, that goes to 0 as well. Goes to 0. So what I really end up getting is 0 minus 1 over 0 plus 3. Oh, that really is going to become -1 over 3. Our limit's -1/3. And again, if you don't believe / trust that, get your calculator out. Okay. I mean, we need to be able to do these without a calculator, but it doesn't hurt if you've got the time to take a look at that. Minus x. And a lot of times when I'm working on problems myself, just to make sure I'm doing it right, I will go back to the calculator just to check my work. Because again, I'm a visual person, so I like to see things that I'm doing. Okay, graph it. I'm in radians, so I'm good. And you can see it looks like it kind of levels off pretty quickly. If you look at the table. I mean, I'm at 600 something out. I forgot to switch it. Notice it's like negative 0.334, negative 0.3328, negative. It's getting closer and closer to negative 0.3. Okay, so it's going back and forth a little bit, but it's leveling off towards negative 0.333, which is negative 1/3. Okay. So hopefully this makes sense. If there's something that doesn't, again, come on in Monday morning or whatever this is. If I use it next year, I guess. And I'll try to help you out. All right, thanks.